In the previous video, we talked about the domain events pattern. I showed you how we can use domain events to extract logic for communicating with external services into our domain event handlers. And in this video, I'm going to show you how we can publish our domain events using the Outbox pattern. The Outbox pattern is useful when you need to guarantee that your transaction will complete in an atomic fashion. Inside of the transaction, you generate one or more Outbox messages and you save them into the Outbox. And at a later time, you process the Outbox and you publish the messages one by one so that they are handled by their respective consumers. We are going to start off from the create member command handler. I'm going to briefly walk you through what we have going on in here. We are first creating our email, first name and last name. We are doing an email uniqueness check to make sure that no other member has the same email as the member that we are trying to create. We are creating a new member using the factory method on the member entity. We are inserting the member into the repository. We are saving the changes and we are returning the ID of the newly created member. I want to show you the member create method. As you can see, here we are just calling the constructor and passing in all of the arguments to create a new member. And then we are raising a new member registered domain event. This domain event is handled by the member registered domain event handler, which you can see here. This event handler has two dependencies, the member repository and the email service. The handle method is very simple. We are just fetching the member from the repository. And if the member is not null, we are sending the member a welcome email using our email service. If you watched the previous video, you are already familiar with all of this. Let's see how we would actually publish our domain event so that we can handle it in the background. Let's go back to the create member command handler. We are going to need two components to make this work. One is going to be the mechanism for persisting domain events inside of the Outbox, and the other is going to be a background job that's going to process the Outbox and publish all of the messages. For saving the domain events into an Outbox, I'm going to rely on our unit of work, particularly the save changes method, which is going to be implemented by NAD framework. And I'm going to use database interceptors on NAD framework to make this work. And I'll show you how in just a moment. Inside of the persistence project, I already prepared an Outbox message entity. This is the format that we are going to follow for persisting our domain events. The Outbox message is going to contain the type of the domain event, the content, which will be serialized as a JSON string, and then some contextual information for processing the message at a later point. All right, I'm going to create a new folder here, which I will call Interceptors. Inside of this folder, I'm going to create a new database interceptor. I will call it Convert Domain Events to Outbox Messages Interceptor. All right, I'm going to make it public, sealed, and it has to inherit from the save changes interceptor, which is coming from NAD framework. This interceptor comes with a few methods that are already implemented. The one we are interested in overriding is the saving changes async method, which is going to be called when we are calling the save changes on our unit of work. Let me format this a little better. This is going to be default, and I'm going to add the curly braces. All right, what we want to do here is on the event data, get the database context, and I'm going to store it inside of a variable. Notice that it can be nullable, so I'm going to say if dbContext is null, just return the base save changes async call. All right, and now what I want to do is access our change tracker, which will contain all of the entities that the dbContext is currently tracking. So I'm going to say dbContext change tracker, and I want to access all of the entries in this dbContext, which are of type aggregate root, because only our aggregate roots can raise domain events. This call returns a collection of entity entries, but what we are actually interested in is the aggregate root instances. So I'm going to select them with a call to select and grab the actual entity. All right, now that we have our aggregate roots, we have to select the domain events that have been raised in this transaction. To do that, I'm going to call select many, because each aggregate root is going to contain a collection of domain events. And I'm going to write a lambda method here for selecting our domain events. If we go to our aggregate root class, we can see that we only have a method for raising the domain events. We are going to need two methods here. One for selecting the domain events. So I'm going to return a read-only collection of iDomain event. I will call it getDomainEvents, and it's going to return domain events to list because I want to return a new collection. And another method that we are going to need will be the clearDomainEvents method, which will clear the internal domain events list. All right, back to our interceptor. Now we have a mechanism for selecting our domain events. We can call getDomainEvents on the aggregate root, and let me rename this variable so that it's more clear what we are calling. After getting the domain events, I'm going to clear the internal collection, and I'm going to return the domain events to satisfy the call to select many. After we have fetched all of our domain events, we can materialize them with a call of toList. And of course, we need to save that inside of a variable. All right, we are almost there. At this point, we have a list of domain events, but what we actually need is a list of Outbox message entities. So I'm going to chain one more call to select, which is going to convert a domain event into a new Outbox message. All right, and what I need to do here is set a few of these variables: the ID, the occurred on date and time to the current UTC now. The Outbox message type is going to be the domain event type, or rather the name of the domain event type. And the content is going to be the domain event serialized as a JSON string. So I'm going to use Newtonsoft JSON for that. I'm going to say JSON convert serialize object and pass in our domain event. And I'm going to need to pass in one more argument, which is going to be the JSON serializer settings, because I need to set the type name handling property to the type name handling all value. What this is going to do is when it serializes our JSON value, it's also going to store the type of the object that was serialized. This will allow us at a later point when we are consuming the Outbox messages to be able to deserialize the JSON into an iDomain event object that we can publish using Mediator. All right, now that we have a list of Outbox messages, all we need to do is use the DB context, set Outbox message call, and call add range on it, and pass in our list of Outbox messages. Now we have our database interceptor for converting the raised domain events into Outbox messages. Let's see if this actually works. I'm going to place a breakpoint here. And before starting the application, we of course need to somehow wire this up. Inside of program.cs, where I am configuring the database context, I need to tell it to use our interceptor. Here, right before registering our database context, I'm going to add another singleton service, which is going to be our interceptor. So interceptor, and let me quickly find it. All right. We need to tell the DB context to actually use this interceptor. We can do that here inside of the DB context call, but I'm going to need to use a different override for registering our DB context. I'm going to use the one with a service provider. I first need to get the interceptor and then pass it to SQL Server. So I'm going to say interceptor is the service provider, get service, get our convert domain events to Outbox messages interceptor. Now that we have resolved our interceptor, I can chain a call to the use SQL Server method, and I'm going to call the add interceptors method and pass in our interceptor. Now that everything is wired up, we can go ahead and test to see if this actually works. I'm going to additionally add a breakpoint at the start of the create member command handler, and now we can start our application. I'm going to head over to Postman. Inside of Postman, I already prepared a request for registering a new member. I'm just going to change the email here to something I didn't use while testing, and I'm going to send this request. We hit our breakpoint inside of the create member command handler. We create our email, first name, last name. We check that the email is unique. Now we create a new member, which, remember, raises the domain event. We add it to the repository, and we call the save changes method on the unit of work. This is going to trigger our interceptor, which you can see here. And now we can proceed to convert our domain events into Outbox messages. I'm going to place a breakpoint here inside of the select many call so that you can see that we are actually going inside of it, and I will press continue. As you can see, we are inside of our select many, where we have the aggregate root instance, which is our member entity, we get the domain events, and we only have one single domain event, which is the member registered domain event. We clear the domain events on the aggregate route, and we return the domain events through the select many call so that it can be used later to be converted into an outbox message. I'm going to place a breakpoint here and continue. Let's take a look at our outbox messages collection. We only have one outbox message because we only raised one domain event. And if you take a look inside, you can see that the type is properly set to the member registered domain event. We assigned the outbox message some random ID, and we serialized our domain event as a JSON string. We now add it to the database context and continue with our save changes call. Back in our create member command handler, everything is completed successfully. If you take a look at the output window, you can see that we have two insert statements. One is the insert into the members table, which creates a new member, and another is the insert into the outbox messages table, which saves our new outbox message. So we are persisting our entity and our domain event serialized as an outbox message inside of the same transaction. This is what guarantees that our transaction is always going to complete in an atomic fashion and allows us to process the outbox messages later in the background using a background job. I'm going to press continue to complete our API call. We get our new member. Let's actually check that it is persisted in the database. I prepared a GET request for fetching the member from the API. I'm going to specify the ID of the member that we just created, and if I send a GET request, you can see that we are getting the ID and the email of the newly created member. This was the first component that we needed to allow us to persist our domain events, and now we need a way to process our domain events in the background. I'm going to create the background job for processing the outbox messages inside of the infrastructure project. For this, I'm going to introduce a new NuGet package inside of the project. The NuGet package that I need is called Quartz. Let's go ahead and install it. All right, now that it is installed, we can create our new background job. So let me add a new folder, which I will call background jobs. And inside of it, I'm going to create a new class, which I will call process outbox messages job. All right, let's get rid of these using statements. I'm going to make the class public, and it's going to inherit from the iJob interface coming from the Quartz namespace. It has to implement this interface, and the only method it has is the execute method. This is where we place the logic for executing our background job. So I'm going to add an attribute here, which will prevent concurrent execution of our background job. I only ever want to have one instance of the background job running. The interesting thing with Quartz is that the background jobs are created from a custom service scope, which means that the background jobs have a scoped lifetime, and this means that we can inject scoped services. The first service that I'm going to inject is going to be our application DB context coming from the persistence project, which I will reference now. The second service that we need is the iPublisher from the mediator library, which will allow us to publish our domain events. Let's create the required constructor, and let's see how we would implement our background job. I'm going to make this method async, get rid of this exception, and move to a statement definition of the method. The first thing that we need to do is to fetch our messages from the database. So I'm going to say db context set outbox message. I'm going to select the messages where the processed on date is null, and I'm only going to take a small batch of messages, let's say 20 at a time, and materialize them using toList. We can additionally pass in the cancellation token, which is available on the job execution context. And of course, we need to await this call to materialize the messages into a list. Now that we have our messages, we can iterate over them using a for each loop. And for a single message, what we need to do now is to deserialize the content of our outbox message into a domain event. So to do that, I'm going to use the JSON convert. I'm going to call the deserialize object method, and I'm going to pass in a generic argument, which will be our domain event type. And the parameter is going to be the outbox message content value. Notice that the deserialization returns a nullable iDomain event instance. So let's, for example, if the domain event is null, continue with our for each loop. In a real world scenario, you shouldn't do this. I advise that you either add proper logging here or actually debug why you are getting a null when deserializing an iDomain event. Now that we have our domain event instance, we can publish it using the publisher from Mediator, pass in the domain event, and we can pass in the cancellation token. Why not? After we have published our domain event, we need to mark the outbox message as processed. So I'm going to set the outbox message processed on property to the current UTC now time. After the entire loop completes, I'm going to call the dbContext save changes method to save the changes that we made on the outbox messages. We are missing a very important component here, which is exception handling. The publishing of your domain events can and will fail at some point, so you need to wrap this in a try-catch block and handle the exceptions accordingly. I'm not going to do that as part of this video. I leave this as a little homework for you. I'm going to place a breakpoint at the start of our background job. Before we run the application, we need to quickly configure our background job. Back in program.cs, I need to be able to register our background job. For this, I'm going to add one more NuGet package. It also comes from the Quartz library. The one that I need is the Quartz extensions hosting library, which integrates with the background service in ASP.NET Core. All right, now that it's installed, I can go ahead and register our background job. I'm going to add Quartz to our services, and I'm going to configure it to register our background job. All right, let's configure our background job. To do that, I'm going to create a new job key, and I'm going to pass in the name of our background job, which is going to be the process outbox messages job. Now I'm going to call configure.addJob, specify our background job, pass in the job key, chain a call to add trigger, which will allow us to specify how often we want our background job to run. I'm going to say trigger for job and pass in the same job key that we just created. I'm going to say with simple schedule. This will allow me to configure the actual interval for running our job. I'm going to say schedule with interval in seconds, and let's say we want to run our job every 10 seconds, and I want it to repeat forever. So this is our configuration for our background job. We also need to tell Quartz to resolve our background job using the native dependency injection. So I'm going to say configure use Microsoft dependency injection job factory, and this will actually resolve our background jobs. And I'm going to add one more service. I'm going to say builder services add Quartz hosted service. Hopefully now we have everything in place to be able to run our background job. So I'm going to start the application. And as you can see, we hit the breakpoint inside of our background job. So let's walk through it and see what happens. First, we fetch our outbox messages from the database. And as you can see, we have one message which was not processed. And this is our member register domain event, which was created a few minutes ago. We go into the for each loop. And the first thing we do is we deserialize the content of our outbox message into a domain event instance. As you can see, this completes successfully and we get a member registered domain event instance. This instance inherits from iDomain event, and we can publish it using Mediator. This domain event is handled by the member registered domain event handler. I'm going to place a breakpoint inside of the handle method of this class. Back in our process outbox messages job, I'm also going to place a breakpoint here so that we can more easily return. And let's hit continue. And what I expect to happen is that we hit the breakpoint inside of our domain event handler, which is exactly what happens. We now go ahead and fetch our member from the repository. We obviously get a member back from the database, and we send him a welcome email, which completes our domain event handler. Going to press continue. Here we mark our outbox message as processed so that it will not be processed again when the background job runs one more time. This completes our for each loop, and we save the changes one more time, and this completes our background job. Alright, this was a long video, but we covered a lot of topics. I showed you how we can use database interceptors to process our domain events and convert them into outbox messages and persist all of them together inside of the same transaction as the changes that were made to our domain entities. Then I showed you how we can use the Quartz library to create a simple background job that is going to fetch the unprocessed messages from the database, publish them one by one using Mediator, and mark them as processed so that they are not handled again when the background job runs one more time. If you like this video, make sure that you subscribe to the channel. Consider turning on notifications so that you are notified whenever I publish a new video, and until next time, stay awesome.